Okay, this is lab 4, focusing on oscillations. So to get started, I'll talk through some of the key concepts involved in this lab. It starts with the first fundamental principle, which is Newton's second law, the momentum principle. And from this, we can derive the velocity and position update formulas and the formulas for gravitational and spring force. And then we also are adding the energy principle into this lab. So change in energy is equal to work, which is equal to kinetic energy plus gravitational potential energy plus the spring potential energy. So the purpose of this lab was to compare the recorded and predicted motion of a mass oscillating on the end of a spring. So I used Tracker to obtain the observed motion data, and then I imported that into a CSV file in Excel and compared that data to what GlowScript code created and predicted data. So to walk through the code, first I started by updating the mass of the ball and then the original position of the ball and the velocity of the ball based on what my data and tracker provided. And then I imported the constant for gravity, the spring constant, and the relaxed length of the spring. And then I put that L is equal to the position of the ball minus the position of the spring, meaning the length of the spring. And then L hat is L divided by the magnitude of L, and the value of S is the magnitude of L minus L naught. So this is the change from the original length of the spring. And then I updated the formulas for kinetic energy and then potential energy for gravity in the spring, and then total energy using the first slide's formulas. And then in the second section of code for the while loop, I imported the formula for fgrav, which is just negative mg in a vector form, and then the spring formula, and I combined those two forces into net force. And then I used the velocity and position update formulas, and I once again imported the L and L hat and S formulas from the last page of code. And then here, these are the formulas for kinetic, potential gravitational, potential spring energy, and total energy. Once again, just updated for the second section of the while loop. So after running the code, this is what GlowScript outputted. You can see the spring moving. The red dot represents the experimental data that I collected in the CSV file, and the blue dot is GlowScript's predicted motion, and they're following each other pretty closely. And then it also outputted these three graphs. So the first what if question was, is the energy principle satisfied? So it is definitely satisfied, and we know this because the orange line on the graph that GlowScript outputted is equal to delta E, and if the energy principle is satisfied, then delta E should equal 0. And the orange line is constant at the value of 0, meaning that the energy principle is satisfied. And then moving on to the second what if question, it asked us to compare the estimates of oscillation periods in the experimental data. So using the X position data, I found that the oscillation period is 1.77 seconds, and the Y position data showed that it's 1.55 seconds. And the discrepancy between these two is potentially due to the fact that more forces, like gravity and the spring force, are acting on the Y component, or those forces are working at a higher magnitude than they are in the X direction, where gravity and spring forces are not necessarily as strong. And quickly to add, some potential limitations of this lab are that we didn't account for drag force or air resistance, and these could create the discrepancies between our predicted and experimental data as well.